All right, class, this is the second video for Chapter 7, Lesson 5 on solving two-step equations using distributive property. Now, these next two examples are exactly the same thing we've been doing over and over again. You guys should be tired by now of hearing this and seeing it over and over again, but if that's true, then that means you're learning what's going on, I hope. If it's new every single time, that might be a little scary, but we'll deal with that when we see each other in class. Now, here we have two more examples that are a little different, but are very, very easy to work with. Let's go ahead and look at and focus on example number 3. So, example number 3 is a little different, is because it has a rational number or a fraction in front instead of a whole number. So, the process is exactly the same. It's just how we handle that fraction that's a little different. So, this shouldn't really be intimidating for anybody. Now, let's go ahead and make our chart and get some paper to do our example. Let's rewrite our algebraic equation first. Nice and big. Perfect. Now, what we have here is multiplication and parentheses going on. Whoops, let me get rid of that. There. Now, let's find our variable. Just like we did last time, our variable is going to be n. Let's make a t-chart. We see that we are adding 6 in parentheses, and then on the outside we're multiplying by the fraction 2/3. All right, well, this is going to be really easy to handle. Now, first of all, we know that the opposite of adding 6 is going to be subtract 6. No question there. Here's where it changes a little bit. To undo multiplying times a fraction, instead of dividing, you'll multiply again, but this time you'll multiply by the reciprocal, which means this fraction is going to get flipped upside down. 3/2. Because when you multiply a fraction times its reciprocal, that makes it equal to 1, which will cancel it out. And that's always what we want to do. We want to get rid of stuff and get our letter, our variable, all by itself. So these are the two steps we're going to use. Just like in the previous examples, we get rid of whatever's on the outside of parentheses. In this case, that 2/3. We're going to get rid of this 2/3 by multiplying it times this fraction, 3/2. So I'm going to multiply this fraction times 3/2, and this whole number times 3/2. Now, there's a lot of math going on here, so try to bear with me as I explain what's happening. On the left-hand side, when you multiply fractions, you multiply the numerators first. So 3 times 2 would be 6. The denominators next. 2 times 3 would also be equal to 6. What's 6/6? 1. So that means this whole thing turns into a big 1. And that means this stuff just goes ahead and drops down now. N plus 6. Because that 1 doesn't change anything when you multiply it. And if you don't believe me, pick any number you want, multiply it times 1, and ask yourself, did my number change? Now the equal sign goes ahead and drops on down. And now we have some math over here. We have a whole number times a fraction. Well, we have to make both of these a fraction, and the easiest way to do that is to put 10/1. Now, use the same rules as before. 10 times 3 in the numerators is 30, and 1 times 2 in the denominator is 2. This is a division problem still. What is 30 divided by 2? Well, that's 15. So I'm going to kind of scratch this out now, and I have this equation. N plus 6 equals 15. Well, I did this part, which seemed complicated, but was actually quite easy. I'm going to go ahead and do the next step, which is just subtract 6 from both sides. Notice that my parentheses are not separating anything, so I can go ahead and get rid of them digitally. You can erase them if you have a pencil, or just ignore them if you did them in something else. And I'm going to go ahead and show the subtraction of 6 from here and from here. My n has never been touched underneath, so it just comes right on down. Plus 6 minus 6 goes away. My equal sign comes on down, continues to fall like always. And I have the math, 15 minus 6. 15 take away 6 is 9. But we got to prove it, right? So that's what we're going to do next. 2/3 times n plus 6, we hope, equals 10. 2/3 times, we said n is equal to 9. 9 plus 6 equals 10. And when we do PEMDAS, parentheses come first. 9 plus 6 is 15 times 2/3 equals 10. Now we have some multiplication here. Let's make 15 into a fraction. Multiply our numerators. 2 times 15 is 30. 3 times 1 is 3. What's 30 divided by 3? 10. And that also equals the 10 we have over here. So since this is true, that means our answer is correct. And that's how you handle rational numbers when you're doing these kinds of problems. Not too bad. Of course, once again, ask or write down any questions to be asked tomorrow in class, please, or in the morning whenever you come to tutoring. It's very important to know how to solve these because these are the most typical kinds of problems you're going to be asked on tests. Now, I'm going to move on to the final example, which is example number 4. Example 4 has a decimal in front. Still, even easier or just as easy as every other problem. Absolutely nothing has changed. So let's begin the process one last time for this video. And don't get me wrong, I'm with you when you say it gets a little exhausting doing these over and over again. But nonetheless, we got to do it. So let's just truck on through. We have 0 plus 2 times c minus 3 equals negative 10. All right, let's talk about our variable c in the t-chart. What do we see happening to it? We see that c is being subtracted by 3, no pun intended, in the parentheses, and being multiplied times the decimal 0.2. So times, and then 0.2. Try to make that a little more obvious. Don't want to get the multiplication dot and the decimal confused. Now, what is the inverse of both of those things? Well, the opposite of subtracting 3 is adding 3. And the opposite of multiplying by 0.2 is dividing by 0.2. Notice that the only time we had to do anything different was when we had a rational number, the fraction. Otherwise, everything is just pretty standard. Let me make this a little more defined. Dividing by 0.2, that's better. All right, so let's go ahead now and figure out. We need to get rid of this number in front of the parentheses, so we're going to divide both sides by 0.2. Divide this by 0.2 and this by 0.2. And don't worry if you don't understand what's happening all up here. All you have to know is that if you have some number multiplied and then divided by the same exact number, which we have here, that they will cancel out, and whatever was left over will just come right on down. Now we have some different kind of math. 10 divided by, or negative 10 divided by 0.2. Well, first let's figure out the sign. A positive divided by a negative is going to be a negative. Okay, so that part's figured out. Now what's 10 divided by 0.2? Well, let's just do the decimal work. 10 divided by 0.2. We learned previously that we don't divide by decimals, we have to move it over. So I'll move this decimal over once to become a 2. And then the one that was in here that was invisible also moves over one more time, and this becomes 100. All right, so now I ask myself, how many times does 2 go into 1? It doesn't. But 2 will go into 10 5 times. 5 times 2 is 10. I have nothing left over, but I do have this extra 0, which just travels on with my answer. So now I know I have a negative 50 over here. I took care of this first step. I took care of the division. Now all I have to do is add 3 to both sides. I'll add 3 here, and I'll add 3 to my answer on the right-hand side. Notice my variable c was not touched, so it drops on down. If I owed you 3 and then I paid you 3, that equals nothing. So I write nothing. My equal sign travels down. Now, negative 50 plus 3. Try to picture a number line, if you can. Negative 50 is going to be on the far left-hand side of that number line. Something like, I don't know, something like this. Here's 0. Negative 50 is way over here. Plus means you're going to go to the right 3 steps. If you did that correctly in your head, you should end up at negative 47. But it's possible we make mistakes, so we need to check our work to make sure that it's correct. So I'll go ahead and check it. I have 0.2 times c minus 3 equaling negative 10, we hope. Wherever I see a c, I'm going to plug in my number of negative 47. Now I use PEMDAS, or the order of operations. I know parentheses comes first. If I'm at negative 47 and I go to the left 3 more numbers, I end up at negative 50. Multiply that times 0.2. And for those of you who may need maybe need to see the work, I'll do it for you. 50 times 0.2. 2 times 0 is 0. 5 times 2 is 10. I have one number past the decimal point, so I move the decimal 1 point in. So that means this gives me a 10. A positive times a negative is a negative. This does check out, which means my solution of negative 47 is true, or correct in this case. And when I look back, same thing we have right here. Now your job is to go ahead and do D, E, and F on a separate sheet of paper and write your answers on the column to the right. As always, feel free to come see me with any questions you have in the morning, or if you just want to get your work checked. And if not, then I will see you in class for a discussion. Thank you very much.